Hello students, I am Ananda Shankar Misra, Assistant Professor in Mechanical Department in Silverberg University. In today's lecture, we will discuss about lathe machine, which is a very important topic in workshop technology subject. So we have found some objectives. Here are some objectives. Main purpose of the century lathe. Century lathe generally is a types of lathe and safety precautions on the century lathe. When we operating lathe machines or any machinery equipments, then we follow some rules or use some precautions. Next, types of lathe. We discuss about types of lathe. Identify main parts of the century lathe. So we discuss about main parts of the lathe machines and the purpose of each main parts and method of holding work. So purpose of century lathe or lathe machines. The lathe is used for producing cylindrical work. When we need a cylindrical object from a square or rectangular shape or from a irregular shape object, then we used lathe machines. And here the workpiece is rotate and the cutting tool movement is controlled by the machines or an operator. Century lathe. Lathe may be operated directly by people. When it is operated by a people, then it is called manual, and when it is operated by machine or computer, then it is called semi-automated or automated machines. Here is an example which is CNC machines, which is computer controlled lathe machines. In CNC machines, we use some code or programming for operated this machine. And here is some safety precautions. Always wear approved safety glasses. We use safety glasses because there are some flying metal particles or it is a protection from dust. Roll up of sleeves, remove ties and tuck in loose clothing. So we fold our clothes up to the elbow. Never operated machines if safety guards removed. So before start machines, we check the safety guards and stop lathe before major works on clean or oil adjust machines. Always remove chuck key after use. So before start a machines, we remove chuck key, which is generally used for tightening the object. Always remove chips with brush. So to remove the unwanted particles or dust, there we use brush because the particles are very sharp. Also we can use gloves, mask for the safety. Next type of lathe. So engine lathe is a type of lathe, the most common form of lathe. So it is generally used for a school or college, and it is a motor driven. Large variety of size and shapes are available, and not it is not used for productions. And the next type of lathe is bench lathe, a benchtop model used for low power used to make precision machines small workspaces. So bench lathe are used for small work and it is not useful for heavy work, and here precision is high. Pressure lathe, a lathe that has the ability to follow a template to copy a shape of counter. So it is a very fast process and it is generally used for mass production. And the next is automatic lathe. A lathe is which is the workspace is automatically feed and removed without use of an operator. So here the feeding process is automated. There is no need for a human or an operator. So it is an advantage. The next is turret lathe. Lathe which have multiple tools mounted on turret, either attached to the tailstock or the cross slide. Turret generally used for holding the tools, cutting tools, and here we can attach multiple tools at a time, which allows for quick change in tooling and cutting operations. So where multiple cutting operation is required, then we used turret lathe. So the next is computer controlled lathe. It is a highly automated lathe where both cutting, loading, tool changing, parts unloading are automatically controlled by computer coding. We have already discussed CNC is a automated lathe and it is operated by coding, which is M code or G code. Next is lathe parts. Here we can see this is chuck where we can hold the job. Here we using a steel bar. So it is left hand side. Next is coolant. When we working on lathe, the heat is produced. So for cooling we used coolant. Next cross side, and here is turret where we can hold the tool, cutting tool. The next part we discussed about the separated parts, which is headstock. So it is mainly in left hand side in the lathe, and the stock spindle. It is the image of lathe. It is headstock. This portion is headstock. This is chuck, and it is belt pulley. Belt pulley are used mainly for transmission. We can change the speed by using this lever, and it is the tailstock. This portion is tailstock. It's a lead screw, and it is turret. By using this wheel, we can slide it across the lathe. Headstock clamped on left hand end of blade. Headstock spindle, hollow cylindrical shaft supported by bearing for smoothly rotation and providing drive through gears to work holding device, and live century faceplate which are fitted to the spindle nose to hold and drive work. It is mainly used for holding the workpiece and driven by stepped pulley, uh, which is belt pulley, stepped pulley, and transmission gears for rotations. Next is lathe bed, which is casted and it is heavy, on which the lathe total mounted and made to support working parts on lathe. On top sections are machined ways, guard and aligns major parts on lathe. So this is the image of lathe bed. On this lathe bed, the lathe headstock and tailstock is mounted. Here the headstock and tailstock are mounted. Next is carriage, used to move cutting tools along lathe bed and consists of three main parts: saddle, each shaped casting mounted on top of lathe and provide means of mounting cross slide and apron. cross slide and apron. So carriage where on which a cutting tool are mounted. This is carriage. This is saddle. This is saddle and carriage. We can move it across the lathe, and here is the lead screw. Cross slide mounted on top of saddle and provide manual or automated cross movement for cutting tools, and compound rails fitted on top of cross slide used to support cutting tools, and swivel to any angle for taper turning. It is an operation taper turning and has guarded collar that ensure accurate cutting tool setting. And this is the image of cross slide. Next is apron fastened to saddle and house gear and mechanism required to move carriage or cross slide automatically, and looking of lever inside apron prevent engaging split knot lever and automatic fit lever at same time, and apron handle wheel turned manually to move carriage along lathe bed. So apron generally used to support the carriage. This is the apron and this is the saddle and this is the carriage, and by using this apron here various of mechanism we can used. By using this apron wheel we can slide the saddle parallelly, and next is tailstock, upper and lower tailstock casting adjust for taper or parallel turning by two screw set in base. Tailstock clamp lock tailstock is any positions along bed of the lathe. It is generally the parallel of the working job. Tailstock spindle has internal taper to receive bed century. By using this tailstock, we can identify the center of the job and providing support for right hand work. When the workpiece is lengthy, then tailstock used for supported the job. This is the image of tailstock. This is the hand wheel and dead center. By dead center, we can identify the center of job, and tailstock saddle clamp. By using this clamp, we can fix the dead center, and it is tailstock move parallel to the lathe. And next topic is tail tool post. There are three main types of tool post used for holding lathe cutting tools: ring and rocker, four-way turret, and quick change. Ring and rocker. With this type, tools are quickly adjusted at century height by moving the rocker, which beats on the tooth ring around the main parts. So, by using this ring rocker mechanism, we can adjust the tool height. Next is four-way tool posts. So, in four-way tool post, it is generally in square shape, and These are the screw to fit the cutting tool. So which allow for cutting tools to be held at the same time. We can use the cutting tool in 4 corners. So next is quick change. No needs for packing. The adjustment is done by means of screw. There are separate tool holes that fit the foreface of the main block and are easily removed and returned to exactly the same setting. This is the slot to fit this tool, and we can change it very easily. For this it is called quick change mechanism. And this is the tool slot. Only we can support it by sliding. Next is compound slide, top slide. It is fixed on top of the cross slide and can be turned to any desired angle. The compound slide is useful for turning and boring slot tappers and chamfer. And this tool generally used for tapering process and chamfering process. And it is fixed, we cannot change it easily. Quick change gearbox contains number of different size of gears and it is generally used for transmission. Provide feed rod and lead screw with various speed for turning and thread cutting operations. So it is generally used for turning process and thread cutting operations. And feed rod advantages carries when automatic feed lever engaged, and lead screw advantage that it is carriage for thread cutting operations when split null lever engaged. By using this lead screw and split nut lever mechanism, we can move the tool post reverse and forward automatically. Quick change gearbox. This is the gearbox, and here different diameters gears are available for transmission. Next, the cutting speed. Cutting speed for turning is the speed at which the work rotates. This is the workpiece, and this is also known as surface speed of the object. Next, cutting speed, rate at which point on work circuit interface travel for fast cutting tools and expressed in meters per minute. So the unit is meters per minute, and important to use correct speed for interior and too high cutting tool breaks down rapidly. So we can operate it at too high speed. Also, in the lower speed, the time lost and low production which happen. So the speed is main factor to operation in lathe machines. Cutting speed selection. The softer the work material, the faster the recommended cutting speed. When the material is soft, then the speed will be more. And here we can see steel, iron, aluminum and lead. Lead is more softer than aluminum. Aluminum also more softer than iron. So the cutting speed increasing rapidly. Next, the harden of the cutting tools materials has a great deal to do with the recommended cutting speed. The harder the cutting tools material, the faster the cutting speed, and the softer the cutting tool materials, the slower the recommended cutting speed. So the tools which is made of carbon steel, high speed steel and carbide. When the cutting tool made from harder material, then the speed will be higher, and when it is made from softer material, then speed will be low. In previous, when the job is from soft material, the speed will be high. When the job material is harder, the speed will be low. And here, the cutting tool, which is from harder material, then cutting speed will be high. When the cutting tool made from softer material, then cutting speed will be low. The depth of cut and the feed rate will also affect the cutting speed, but not to as great an extent as the work hardness. So depth of cut, when the more depth is required, then cutting speed will slow, and when less depth is required, then cutting speed will be fast. Next, the factor that affecting the cutting speed. The material being cut means the job which is made from harder material, the cutting speed will be low, and when it is made from softer material, cutting speed will be high. So it depends on job material or workpiece material. Next, the rigidity and condition of the machines. So it also depends on machines conditions. The material of which the tool is made from. When the tool is made from harder material, cutting speed will be high. When it is the cutting tool is made from softer material, then cutting speed will be low. So it is also depends on cutting tool, the depth of the cut, and feed rate. Feed rate, when feed rate is high and the depth of cut is required more, then speed also will be low. When feed rate is high, the cutting speed will be high. Availability of the coolant, when coolant is sufficient, that time the cutting speed will be high, because the more coolant will sink the more heat. So it also depends on cutting fluid. The next topic we will discuss, explain the lathe accessories and explain the accessories used in the metal workshop. And what is lathe accessories? Equipments or tool used on the lathe to assist in performing an operation. Lathe accessories divided into two categories: work holding, supporting, driving devices. Lathe sentry, chuck, faceplate, main steady and follower rest, lathe rows, and drive plates. And cutting tools, straight and offset toolbar, tool holder and threading tool holder, boring burrs, and turret type tool post. Chuck, which is the main part in lathe, and it is generally used for holding the workpiece, and it is mounted on headstock. Chuck used extensively for holding work for machining operations, work large or unusual shapes, and most commonly used lathe chucks, 3-jaw universal, 4-jaw dependent, and collect chuck. So in lathe generally there are three types of chuck. 3-jaw universal chuck, here generally use 3 jaws, and this is the key way. By using the key we can tight or loose the workpiece. When we lose the jaw, then it's moved towards the circumference, and when tightening it, it comes to the center. And 3-jaw universal jaw generally used for hold round and hexagonal works. When the jaw or workspace is in a round shape or in hexagonal shape, that times we used 3-jaw universal. Graphs are quickly and accurate for fast working process, and when needs more accuracy, that time also used 3-jaw universal chuck. 3 jaws moves simultaneously when adjusted by the chuck key. The next 4-jaw independent chuck used to hold round, square, hexagonal, and irregular shape workspace. So in 3-jaw chuck, we generally used round and hexagonal workpiece, and in 4-jaw chuck, we can use different types like round, square, hexagonal. Also, we can use irregular shape workpiece. Has 4 jaws, each can be adjusted independently by chuck key, and jaw can be reversed to hold work by inside diameter. So this is the key slot, and these are the jaws. Headstock spindle, universal and independent chuck fitted to 3 types of headstock spindles. Threaded spindle nose, screw on it in a clockwise direction. So these are the thread generally used for fitting the chuck. Next, tapered spindle nose and held by lock nut, and that are live on chuck. This is the log nut, and generally it is used for like a keyway, and it is different from the threaded. Next is cam lock spindle notch. Here cam lock mechanism is used, and here used mainly for patting the T range, and chuck aligned by tapered, which is by angle on spindle notch. Next, collet chuck. Collet chuck is used to hold small workpiece, and it is generally used for high precision work. Spring collet available to hold round, square, or hexagonal shaped workpiece. So it is also worked on round shape and hexagonal shape or square shape workspace. And each collet has a range of only few thousandths of an inch over or undersized stamped on collet. So it is generally used for small workspace and for high precision work. Next, faceplate. A faceplate is the basic works holding accessory for a lathe, and it is circular metal plate which is fixed on the end of the lathe spindle. The workpiece is then clamped to the faceplate and typically used T-nuts in slot in the faceplate, or less commonly threaded holes in the faceplate itself. So generally faceplate used on the chuck where it is supported the workspace. So faceplate to hold work tools or shaft so it cannot be held in chuck or between centers, usually equipped with several slots to permit use of boards to secure works. So it is generally used to hold large workspace. Also, it is mounted on the chuck. So this is the faceplate, and these are the hold downward ramp to hold the faceplate over the chuck. So this was your today's session. Thank you.